Hello, Spark fans. So I have an apology to make. I did promise 2 videos yesterday, and then I recorded this video and it didn't work, and I recorded it again, and this is attempt number 3. So I promised a run through the Databricks Lakehouse paper, a recent academic paper they put out to describe why the Lakehouse architecture is a thing, what problems they're trying to solve, and essentially kind of their approach for tackling that problem. Very different to the Delta paper we saw last year, which is much more under the hood of the Delta object itself and why they built it that way. They're obviously intrinsically linked, but they are slightly different approaches to the same problem. So we'll dig into that, we'll have a look, and we'll see what we think. Also, yesterday I was talking about funding. So talking about Databricks having a load of investment, having a load of funding, and I was kind of pulling out one interesting one of going, well, we've seen Google, and it makes sense that Google invested, and we've got AWS and Azure. Why's Salesforce investing? And then obviously, as is always the way, immediately after I'd done a video, I go and see that people are posting around the new Einstein Delta Lake. So essentially an engagement lake produced using Databricks Delta under the hood of Salesforce. So it's a super interesting article talking about talking about what's happening inside it, talking about their architectural approach to managing that. And that's super interesting because unlike the other ones where it's we are going to allow Databricks to operate on our platform so that you can access Databricks and just build whatever you want. This is a gigantic application using Databricks to service its application itself as a core part of it. So super interesting development, super interesting to read how they're going about it and what's happening under the hood there. So I'll pop a link to the article. Do go and check it out. All right, let's go and talk about this paper. Again, this twice already. Okay, so this paper, as I said, is going and arguing why the Lakehouse methodology is a thing, where it came from, and the whole point of that approach is. And so it starts off by arguing a little bit about a history, a little bit about, so we used to have warehouses on-prem, and you had to size that warehouse based on the physical highest peak of either user usage or ETL, and then you're stuck with that size. Size it once, and then live with your decision. Hence waterfall processes to decide this, how much growth are we going to have over the life cycle of this thing, and huge amount of planning and preparation for the size and structure of your data. Now, people have moved on. We've seen, okay, we need to move to the cloud. We need to have elastic scale. And the point I mentioned here is kind of, so data sets are growing more and more unstructured. We're dealing with more variety of data. We're dealing with videos and audio and PDFs, all sorts of mad ways of storing data. And it's funny because it kind of argues that this is becoming much more kind of a bigger percentage of the data that a company has. And so many clients I work with who go, no, all of our data is structured. It's like, is it? Or all of the data that you consider your data is structured, and you've got a ton of audio and video and images and other stuff that you don't even think about, that you don't even consider data, was actually starting these systems are going, you can onboard this stuff. You can bring in reams of sensor data. You can bring in your CCTV to track people's flow, and you can do all that kind of stuff, but you wouldn't necessarily put that in a warehouse traditionally. Hence why it's kind of it's a changing evolution of how we think about things. Then talked about the second generation of these systems, so where you have a lake and a warehouse. When you're using your lake as kind of a staging area, you're getting data, raw data into your lake. You may be doing something to make it accessible. You know, kind of you're encoding your audio files into something that you can actually sort of structure. You're putting structure on top of raw data in a lake, and then you put it into a warehouse, and you do your shaping and analytics. You make facts and dimensions and all of that kind of thing. And that's kind of what we talk about as the modern data warehouse out in industry. Okay, modern data warehouse, people go, what's that? Oh, it's a lake and a warehouse, and you use them together. And they talk about some of the problems with that approach. So talk a little bit about history, where it came from, how it grew, what are the key problems with that approach of having these both. And they talk about reliability. They talk about the ETL pain of getting from a lake, getting into the warehouse, and kind of managing that relationship and keeping them up to date, which is kind of how they build into this data staleness, but also just the overhead of maintaining that. And when I first read that, I was like, not that hard. But that is because I already work in a Lakehouse style. I already do all my shaping of facts and dimensions or wide reporting tables and analytical models in the lake. So by the time if I ever need to have a warehouse layer, I'm just moving static object. I'm just saying, take that partition, switch it in. Take that partition, switch it in. I'm just saying, take the file, move it. Don't transform it en route. Don't keep things in. Just literally take this chunk of data, put it over there, and then it's easy. But unless you're doing that, if you're trying to have a straddling thing to, well, I've had an update there, is that up to date? I need to update that. Got dependency models in my warehouse, that gets complicated. So it's easy if you're essentially building a lakehouse and then occasionally shunting a tiny bit of data into a warehouse. It's hard if you're actually trying to manage these two in parallel. They talk about limited support for advanced analytics. So when we're talking about the data science workflow, it's not really supported in many warehouses. Now, we do have things like predict functions. So we can take a data model, we can jam it into a warehouse and then score data on the fly. But that model isn't native in that area. We have to build it externally, build a model that can accept certain input parameters, and then jam it into our SQL Server or relational database. You can't build an experiment and iterate on models in situ in that warehouse. We have to build it externally and plug it in. So yeah, absolutely limited support, and it makes it hard to manage in that way and build these things together. Okay, for me, the killer argument is that total cost of ownership. So the cost, not only of the storage, they mentioned storage as the main thing here, of going, I've got all my data in a lake, I've got another copy of all that data in my warehouse, and I'm paying double for my data. Big thing for me is the cost of compute. That's always the most expensive part in the cloud. So saying, I've got a cluster spun up to do a load of lake pre-processing, another cluster set of computes out of the database engine, whatever it happens to be, spun up to do my warehousing work. And actually, they're both sitting there, both doing lots of work, and I'm paying twice the money. So again, it's TCO not just on storage, but also on the actual engine and compute, and ETL complexity costs money. So then talk about, okay, so where are we going? Where are we building? What would a lakehouse solve? And the normal arguments of, okay, well, simplification of architecture, just do it once. We have a common language to talk across anyone wherever they're talking about. They don't need to know, oh no, this one's in the warehouse. Oh no, you need to go to the lake for that. It's all in the lake. Just makes sense. But I'm so happy they've made this point. So despite all of the cool stuff that lakehouses do, despite all of the advances in technology and all the machine learning stuff you can do and the scalability of all this stuff, it doesn't work by magic. There is still hard work to actually build analytical models. So yeah, sure, it'll make ETL easier. You can build more robust, scalable frameworks. You can build reusable code that just gets rid of a whole slice of the effort of preparing data. It's not going to work out your data model for you. It's not going to tell you, oh no, that should be a fact. You should want to pull out these dimensions. The KPI for predicting that, it's going to be that. What you want some kind of actionable insights. Tell you what, let's measure it based on that, and that. It's not going to do that for you. You still need to have that domain experience and understanding of your data. You still need to work with your data. It just makes everything else easier. So always good seeing that message and going, yes, there's a lot of hype around lake houses, changing everything and being like the next best thing, but it's still not magic. It's still not going to actually design data models for you. And if anyone tells you can, they're probably lying. Support for machine learning and data science. It is built on data frame APIs. We've got things like koalas and pandas and R data frames. All those things that are used by the data science ecosystem are supported in our lakehouse approach. Just makes sense that it's then a lot easier to integrate advanced analytics with traditional analytics. And SQL Performance is one of the biggies. One of the big reasons everyone goes, no, but I have to have a warehouse layer. I can't just live with a lake. I have to have a warehouse for performance. Because I've got people writing SQL queries and I want it to go fast. And that's been like sort of the big argument against having a single thing in a lake for a long time, is this assumption that warehouses will perform more. And a huge amount of the investment that Databricks have been making around improving the Delta format, having all this kind of metadata and data storage and data layout optimizations, having things in the actual engine to better understand SQL and better build out the execution plan for those SQL, is all to tackle that accusation and kind of try and debunk that myth. And probably it's still not quite there. It's really good for a lot of stuff, and you get economies of scale. For big data, it's awesome. For your little, I expect this to come back in, I'm doing single record lookups. Tell me the total for this one figure. And maybe in a warehouse it'll be faster because you can index it more thoroughly. But even that is getting better. So that's what they're tackling. And I think a lot of this paper, actually, I like this paper because it is It's saying, we know we're not there yet. This is what we're trying to do. This is why we believe it's a fantastic approach. This is why I believe we can use it now. But also, here's a load of stuff that we can make better in the future. It's acknowledging that there are alternative paths, alternative approaches, and arguing, going, we think this is the way we should go forward. But there's better ways and other ways, and we acknowledge we can make this better and this better and this better. Let's try and get there. Let's try and move in that direction. Rather than, marketing, this is the best way to do things. Again, I'm going to skip through fairly quickly. Again, I do recommend having a read through the extra detail. A lot of it is talking about the arguments for why they built Delta, why we need something like the Delta file format. And again, if you've read the Delta paper, if you look at the more in-depth video I did on the Delta paper, a lot of these arguments are kind of similar. We need ACID transactions. We need, good structure in our data. So again, talking about the other stuff. So what's already happened towards lakehouses? So they talk about warehouses extending their own way. So not only is lakes getting more and more of the kind of governance, ACID transactions, good kind of data management approaches of warehouses are extending into the lake and being able to query ORC and Parquet and being able to have distributed file formats that actually are separated from the compute layer and all that good stuff. But they can't necessarily deal with audio and video. They can't necessarily deal with some of the advanced AI, data science type stuff. So they're heading in that direction, lakes are heading in that direction. At some point, we might have a true unified data platform. One or two of these points actually sort of surprised me because it's like data lakes still lack basic management such as ACID transactions. Like, no, they don't. That's what Delta's for. But obviously this paper is making the argument as to that's why they put Delta in. So a lot of these arguments may seem familiar. If you've been working in the Lakehouse for so long, you'd be like, yeah, I know. That's why they did it. But this paper is arguing for people coming outside of that. Actually, this is what it means. We talk about having, actually, one of the benefits of separation of storage and compute is we can have different compute profiles for different work on the same data storage. So they talk about having a GPU cluster for doing deep learning and ML. So we can have a really expensive, heavy specialist cluster that I only turn on once in a while to train this one specialist model. Then I've got my big engineering cluster I use for big data management. And then I've got my much smaller profile analytics cluster I use just for serving queries on top of the prepared data. And I can do all that without having to provision 3 different systems. It's just different clusters I spin up all in the same ecosystem across the same data, most importantly. And they mentioned the 3 major programs that have been happening inside Databricks to try and support this. These are their 3-pronged angle of attack to enable these different things. Delta Lake, so the file format with its transaction log, with all of its auditing and statistics and stuff to make that file actually just run better and be more governed and robust. The Delta Engine, which is the improvements around that C++ focused engine to make serving things from SQL a lot better. Make it faster to do things like Python, all that kind of stuff. Generally just to make it perform better. And the Databricks ML runtime, all of the good stuff to make sure data science, data scientist workflows are a first-class citizen within the same ecosystem. It's all good. They talk about how they're implementing it. They talk about lots of detail for that. Again, don't have huge amounts of time to run through. I do advise you have a read through. They talk you 1 or 2 of the bits and pieces that kind of really flick switches that enable people to work. Things like the data quality enforcement. So if you try and insert data into a Delta table and it's the wrong shape, it'll go, no, that doesn't fit the scheme of my table. The same as it would with the SQL table in a database. It'd be like, what is that? No, it's not going in there. You can have constraints. You can have like a robust table that has rules and governance. And you can see investment in that area. So they're expanding it to say, well, actually, there's more and more and more features to understand how you get those abilities. But then if you just switch those on, it can you lose some of the benefits of Lake. Some of the, I can throw in any data. I can be super flexible. And yeah, data is I don't care what the shape is. I'll figure the shape out. I'll apply schema on read. And you lose some of that if you put in these structures. But it's about having that choice. And we're seeing more and more features appear in Delta to be able to say, and actually, you can have structs, which have available amounts of attributes in there. We can have a little bit of flex and some structure in the same data model, which is fantastic. Talk about access control logging, again, very important parts of building a warehouse. Really good to kind of dig in and look at some of the other objects they're talking about. So they're saying, well, Delta Lake is one approach, But Iceberg and Hootie, and there are other open source approaches that are trying to tackle the same thing. This is not the only way. This is the way Databricks have come up with to try and answer these problems, and this is why they're doing it, which, again, is refreshing coming from a cloud vendor actually just saying, this is why we're doing it. It's not just like marketing, we have a new product, buy our product. It's we think this is a problem. This is what we're trying to do to fix the problem. This is our reasoning behind it and where we think it's going. Here's some of the people who are doing some similar stuff, which is all good. I mean, kind of refreshing. They talk about performance. And again, a lot of this kind of bit of crossover with how they're talking about the Delta Lake paper. So I won't go too depth about all that kind of stuff. Again, interesting to see Bloom filters mentioned again, because that's, again, one of those things people go, kind of indexes in Lake, it's never going to perform that well. Putting in Bloom filters, putting in that kind of extra indexing layer could maybe tackle some of that stuff. Honestly, I need to do a lot more research into using Bloom filters to try and add that next level of performance for that Lakehouse style serving model. Okay, looking at the new C++ execution engine for Apache Spark called Delta Engine, and I was like, what's that Photon? Still not sure. And then moving through, and there's some interesting things about them pontificating on the future. So how and when to use serverless computing to answer queries is a super interesting one. I would love to see that kind of throw a SQL query and have it just have some ephemeral compute that answers those questions at a cost, similar to your Synapse SQL pools, serverless SQL pools. That would be great running in the Spark ecosystem, so I can have it all in one area. Again, not seeing anything like that, but I'd love it when we do. But then how do you do caching? How do you manage optimization in those cases? How do you have that as an ongoing thing if you don't have a cluster that you're managing and it just comes up, does a thing, turns off? How do you make it so it comes up quick enough to actually be worthwhile rather than just have a cluster turned on? Loads of interesting things. They talk about a little bit more about integration with advanced analytics and where that's going and how they could get better at doing some things with TensorFlow and that kind of stuff. Again, I should run through it. They are doing massive amounts of work there with things like koalas to try and tackle that exactly. Things that are expecting a pandas data frame. You can make Spark native by giving a koala data frame, all that kind of good stuff. Then some open questions. So what other areas are they looking into? How are they going to, what other ways can you do things? The first one they pull out is the kind of data virtualization. What if you had a separate serving layer, which is sitting across lots of different, rather than having one lake that has a common format of Delta, you've actually got lots of different data stores and databases and other different places of getting data, and you build some kind of data virtualization serving layer that can goes up and pull it across. And they talk about some of the limitations of that, of, you're creating a bottleneck unless you scale it out enough, in which case you're creating cost. If you're doing caching to stop you having to go back, and like tunneling through to these different data stores, caching is expensive. You end up with a very expensive data layer. So to talk about some of the issues there and why it's kind of, they don't see it as the way forward. A lot of people are loving data virtualization tools through Dremio and that kind of thing, where you can just put this in the middle and use it as an intermediate layer, and then that serves out a common API. And that makes integration with it a hell of a lot easier. It's just, how do you make sure it's talking to those under the actual data stores, the raw object stores, actually more efficient? And interesting, just another approach that they're acknowledging. Talking about having different storage layers, I'm basically saying, you know what, you can use lots of different storage layers to achieve the same thing, as long as it has a raw storage format, it has client libraries so other things can understand it, and it has a high-level SQL interface. If you can do that, you can work to achieve a Lakehouse model. And it's not saying you can only do this using our technology. It's saying we think this is a good approach. This is how we've approached it. But it's kind of like a cry out going, can we all just agree to try and do this and have this as our approach, regardless of the method that we use to get there? We can just head in this direction. And then talks about some other data management trends. So other emerging approaches and other kind of ways of working. So Polystore is interesting. I'm really not come across Polystores very much. Kind of leans for me into that same kind of data virtualization layer. It's kind of saying, I've got lots of different disparate storage engines, lots of different techniques for storing my data, and I'm actually creating a common layer across that allows me to run across them. And saying, well, actually, it could work fine, as long as these queries run directly against the object store, not through this intermediate virtualization layer. So as long as you find a way to actually store your data where you like and have also silence the data, as long as you do it and access it in a performant common way, great. Well, lots of different data integration cleaning tools, as long as they can hook in to these native architectures that we're using in the Lakehouse, and they can talk to Delta. Fantastic. Talk about data management in ML. So they're talking about, well, actually, let's make sure that we can, if we're doing things like, we can do things like feature stores. So as the data science trends emerge, so previously saying we need to make sure advanced analytics is part of this ecosystem. And advanced analytics evolves and has new techniques and new approaches and new things. We need to make sure that they can do that in this common architecture. Because if they can't, they're going to end up going and developing their own separate branch of tools and working outside of our common ecosystem. If one area is evolving, we need to make sure they are in the fold, and we can do that. We need to make sure we can do things like feature stores within this whole approach. Talk about cloud native DBS design. So like, actually, if we're having, so for me, the one that cries out is Synapse serverless SQL pools. So having something that can just go and run a query in a very fast, very scalable way, they're kind of just saying that is a great approach, but it only works if they can actually go through the rich metadata management layer. So it only works if things like that can understand Delta. And for me, we know that's a pattern that we're actually quite excited about when it gets there. If we have Databricks actually doing a lot of our data prep and our big engineering and our laying down, essentially creating our Delta lake tables and objects and curated assets, and then having people be able to serve their queries through serverless SQL if they want, talking to that common object layer. Great. As soon as it actually understands Delta, and it has to understand Delta and work with Delta's partitioning and work with file pruning, it needs to be able to use all that optimization layer. Otherwise, it's just doing a blunt force read of everything, and that's no good. Finally, they mentioned data mesh, and I thought this would be an argument because it has been, we hear data mesh as we're not doing data lakehouse because we want to do a data mesh. It's like two conflicting, headbutting ideas. But actually, the way they're saying is actually, you know what? It's just, this comes down, the arguing that data mesh is a different approach to the people who own and design and manage these data assets and curated assets. And actually, you could do that in a lakehouse format. So they're saying lakehouse is actually the concept and the organization and the underpinning technology, the architecture essentially of your data stores. And actually, as long as you adopt that, and as long as all the people who are actually building their data products and the different separate teams that are actually managing their different data assets, as long as they're using this shared architecture and shared collaborative approach, and they're using this common language and format, actually doesn't matter which team produces and consumes it. And that makes sense. I like the data mesh approach of team management and organization and workflow with the underpinning technology of Databricks. It is actually a pattern that can easily work together. And we've seen it done with clients where they had ideas of some centrally managed, like this is the central department, the kind of the center of excellence, call it what you will, make these kind of generic data sets. And then various different teams actually build off that and build their own curated pathways and build their own kind of curated assets that's on top of it. It's becoming a fairly common thing of actually realigning who makes data with the people who understand and own that data. And that approach, rather than saying, no, it's data mesh, it's not a lakehouse, and causing a rift, causing a conflict, it's saying, that's a great bit of a pattern, that's a great bit of a pattern, why don't we get the best of both worlds? And again, it's always nice to see that acknowledged by the vendors pushing it for one particular area. And that's the paper. So much in there. And again, when I first read it, coming from my background, where we're doing a lot of the lakehouse style architectures, where we're constantly trying to do more and more with the technology at hand to actually enable that via the lake and make more use of the lake. When I first read it, it was very much that just makes sense. That's just how we're working. But so much when this term came out, when some people were talking about lake houses, everyone was just this argument of what does it mean to you? No, I think it means that. My interpretation is it's that, but with that twist, having this very clear, this is what the term actually means to us. This is the problem it's trying to fix. This is where we think it's going in the future. These are some of the problems. Having this actually sort of stated very clearly by the guys at Databricks, by kind of the guys behind a lot of this stuff, really, really good. Really, really good to be able to communicate. So if you're actually talking to anyone who's looking at the Lakehouse model and they're thinking about adopting it, or they've heard the buzz and they're like, oh, that should load of hype, it doesn't actually mean anything. Great paper just to say, this is what it means. What does Lakehouse mean? Here is an actual academic paper that explains behind the scenes, this is what it means, this is why it came about, this is what it is. Not that accessible if you want like a shiny marketing buzzword with lots of flashy lights. But if you want just an honest discussion of why it came about, why it came from, why they're putting it that way, and where they think it's going in the future, really good to actually sort of step through and read it and understand it. I think it's quite nice actually sort of doing this in alignment with kind of the Databricks company kickoff that's happening currently, because this is them resetting their goals, going, we've just got funding, heading towards IPO and all that kind of stuff. And what do we actually want to do? Where are we all heading? And this is kind of like a call to action going, this is what we believe in. This is what we think we're going. This is what we want to see improve and mature and get better in the future. So that is all for today. Finally got through the video without things breaking. Happy days. And yeah, as always, don't forget to like and subscribe. Let us know what you think of the paper. I'll drop a link to it. Have a read through. Tell us what you think. Tell us if there's bits that you disagree with. If there's other elements of the bits that they've mentioned, such as patchy iceberg, Hootie, all those kind of things, that you go, actually, this is a lot better. Why don't we take that bit? Really interested to know if there's a little, not just like this whole approach is better, but actually the thing that they do there would be great. The thing that they do over there would be great. But you understand kind of the bits and pieces of those things that go, why don't we just try and push for that? Why don't we actually say, take a bit of that, bit of that, bit of that, and actually come up with the best approach rather than arguing for our own particular favor and saying it's better than all the others. That's what I would like to see going forward. And yeah, who knows? We might get there one day. As always, thanks for watching, and we'll catch you next time. Cheers.